Right, in this video, we're going to cover section 4.R.1, which is called Order of Operations, with real numbers, but we're doing everything with real numbers, so it's really the order of operations that we're studying. By operations, I mean the ways that we can combine two numbers to get another number. And those ways are addition, subtraction, multiplication, and division. Separate them with a comma, but you know the symbols. We really don't use the division symbol very much. We use the fraction notation for division most of the time. The dot, we'll see sometimes that we can just put two things next to each other to mean multiplication. We don't even need the dot. But these are very important symbols that are going to stay with us. But these are the four ways that we have to operate on two numbers to get a third number. Sum, difference, product, and quotient are the names of those operations, but plus, minus, times, and divided by. And for the order of these operations, what it means is, well, we work left to right. If I have 3 plus 2 plus 5, I can add the first two and I get 5, and then I add the next one, I get 10, and that's it. We work left to right. But these operations work in a different order, but also there's a left to right aspect of it. The order of operations, the full order anyway, has a mnemonic to help us remember what that order is. Parentheses come first. That's the first. Parentheses are grouping symbols. There's other grouping symbols like roots. Brackets are exactly the same as parentheses. We'll see a little bit more. Exponents is the next thing that needs to be done in the order of operations. Multiplication and division. Now, they really are part of the same process. They're a reverse process of each other. And those come left to right before addition and subtraction, but after parentheses and exponents. But we could have PEDM, because these two are of equal precedence as we work from left to right. Same with addition and subtraction. Addition and subtraction happen kind of at the same time, but as we go left to right. And we'll see examples of how to do this. So parentheses, exponents, multiplication, division, addition, and subtraction. So the mnemonic can be PEMDAS, the word, or please excuse my dear Aunt Sally. You could, like I mentioned, these are kind of grouped, so you could swap them, but it turns out that it's easy to say like this. Let's look at some examples of how to apply this idea of PEMDAS. So the first example problem I got was -2 times 2 minus 22 divided by 1. And so I'm going to work with parentheses first, but there's nothing to actually do inside of these parentheses, so it is just a -2. I need to look for exponents. No exponents in this. So next, multiplication and division, left to right. And there are two places, multiplication and division. Left to right means I need to do this first. -2 times 2 is -4, minus 22 divided by 1. Now, I could have actually done this step at the same time, because they're separated by this difference. The next step is going to be that. So -4, 22 divided by 1 is 22, so -4 minus 22. And then doing the subtraction. So this is the subtraction. This is a minus sign. So it's a subtle difference, but the minus sign means it's a negative number. The subtraction sign means that I need to do the binary operation of subtraction. I need to subtract one from the other. -4 minus 22, though, is negative 26. So it's really kind of like I'm adding the negative 4 and adding the negative 22, but they're the same sign, so they combine to make a larger negative number. The second problem I got was 1 minus 4 times negative 11. And notice when I write that down, when I say it, I don't say parentheses. You would have to do that if you were trying to communicate math over the phone. You would have to tell the other person where the left parenthesis 1 minus 4 right parenthesis times left parenthesis. But when you're writing it down, you can just say the numbers. Just keep in mind those symbols are very important grouping symbols. In fact, here they tell me that the first thing I need to do is 1 minus 4. That's negative 3. I don't absolutely need these parentheses, but they don't hurt. And then what I have left is negative 3 times negative 11. Now that's a negative times a negative is going to give me a positive. But 3 times 11 is 33. And that's it. What we're doing is sometimes called simplifying numerical expressions. We've got this expression with the operations and numbers. We want to get it down to a single number. Again, that's what we did in this one. We started with this expression, we simplified it down to a single number. For number 3, I've got 4 times 1 minus 25 divided by 5. And I'm going to do this one step at a time. There's no parentheses or exponents, but multiplying and dividing left to right, I come to the multiplication first as I go left to right. So it's 4 minus 25 divided by 5. But this division is going to happen before the subtraction. I could do this division in the first step, but 25 divided by 5 is 5. And if you can go from this directly to this, that's great, that's fine. If you need to take the intermediate step, that's good too, as long as you do them correctly. And then 4 minus 5 is negative 1. The next one that I got is negative 9 squared, and this is a little bit about order of operations, but it's also about notation. What's being squared here? We're not squaring negative 9, we're squaring 9. Only the 9 is squared. So in this case, this is negative 81. The negative isn't part of the expression that's being squared. We'll see some more a little bit like this. In fact, let me just show you. This is the common confusion. People mix these two up. This is negative 9 squared and this is negative 9 squared. I said the same thing, but this is a really good illustration of why math is a written language. And we use verbal language to assist that, but it's the written language that contains the meaning. In this case, negative 9 squared is negative 9 times negative 9, that's 81. Whereas for this problem we had negative 9 squared, which is negative 9 squared is 81. These two are different. In fact, this next one has something related. The absolute value of 18 minus 23 minus negative 5 squared minus 5 squared. So absolute value bars are grouping symbols. So that's kind of like parentheses. That's the first thing that I'm going to do. Even before I do these things with exponents in them. The absolute value bars contain or group these symbols. 18 minus 23 is negative 5. But I'm still going to have it in absolute values. I just did the subtraction. Minus negative 5 squared minus 5 squared. And you could do work on these terms also in that step, but I'm going to break it down to as few things in each step as I can. The next thing, well, there's kind of a couple things here. This is kind of like a grouping symbol, but we don't have absolute value in our order of operations. However, the absolute value of -5 is 5. So we can just write it. Fewer symbols, same thing. Then minus -5 squared. -5 squared is -5 times -5, which is 25, positive 25. So we're subtracting 25. And here, minus 5 squared is also 25. So we're subtracting 25 again. That was doing the exponents part. Also evaluating this absolute value. Now I really have to do subtraction. So 5 minus 25 is -20. And I'm doing it left to right. First this subtraction, now this subtraction. -20 minus 25 is -45. The next problem I got has some decimals. When you have a problem with decimals or with numbers that have like 3 or 4 digits, sometimes even 2 digits is complicated, big numbers, or decimal numbers that have a lot of digits, calculator is the way to go. It's a lot faster than doing it by hand. And for example, number 6 gives me 10.5 divided by 2.1 minus 2.5 squared. So I've got a 3-digit number, kind of. There's 3 digits in this. If I'm going to do division, it's going to take a long time, probably. So I would use a calculator. The first step that I need to do here, though, is the exponent. So this is 10.5 divided by 2.1 minus 2.5 squared. 2.5 times 2.5. I did that on a calculator. I got 6.25. The next thing I need to do is that division. There's no multiplication. We're doing division multiplication left to right since we've done the exponents. 10.5 divided by 2.1 is 5, and then minus 6.25 is going to give me -1.25. So a calculator can be a big help in problems like this. I'm going to clear this because the next problem takes up kind of a lot of space. There's a lot of steps. So this is number 7, and I got 7 minus bracket -1 minus parenthesis -3 times -3 plus -6 parenthesis bracket divided by 4. There's a lot going on in this problem. There's operations and different sign numbers, and so it's good that we have the PEMDAS mnemonic to guide us through this. Parentheses, any kind of grouping symbol. What that means is we need to look at not the brackets, but the inner parentheses, or the innermost parentheses. There's nothing to do, but what we need to focus on is inside of this parentheses. The first thing we're going to need to do is multiply to simplify this interior expression. So I'm going to end up rewriting a lot of it. -7 bracket, -1 minus, 7 minus bracket, -1 minus, this multiplication, -3 times -3 gives me 9, plus -6, and now I'm just recopying the rest of it. So that was really all I did in that first step. -3 times -3 is 9. Next, since I've still got things going on in the parentheses, this is not going to change yet, but 9 plus -6 is 3. You could put that in the parentheses that it comes in, but 9 plus -6 gives me 3 divided by 4. And then I've still got things in the grouping symbol the grouping symbols that I can combine. negative 1 minus 3 is negative 4. Now I'm going to use the rest of it. There's nothing to do in the grouping symbol. There's no exponents, so multiplication, division, left to right, there's no multiplying, but that's the division. Negative 4 divided by 4 is negative 1. So I'm looking at right here, negative 4 divided by 4, negative 1. 7 minus negative 1, that's 7 plus 1, but it's 8. So that whole expression there, 6 different numbers combined in this very specific way, gives me the number 8. Now, if I just worked the whole thing left to right, I'm almost positive I would get a totally different number. We have to use this convention of order of operations so that we always get the same number, so we can at least agree on math. So number 8, I got 2 minus negative 2 squared divided by negative 5 minus 3. So that expression. Before I even get into that, I've got grouped symbols here. I've got a 2 minus negative 2. I've also got a negative 5 minus 3. I'm going to do these in the same step because they're kind of separated from each other. It's going to save some writing. So just write this 2 minus negative 2 is 4. And maybe it's in brackets, it doesn't matter. I need to square that still. But then divide it by negative 5 minus 3, that's negative 8. Now the order of operations, we've done the grouping, the parentheses part. Exponents are next. So this 4 squared, that's 16 divided by negative 8. And this is all that's left. 16 divided by 8 is 2. 16 divided by negative 8 is negative 2. And that's it. The next problem, and I recommend doing this if you get a problem with fractions. Well, a problem with fractions where you have to add or subtract them. That's the common denominator situation. If you write it out, negative 9/10, leave some space, plus 5/6 divided by 2/10 plus 2/7. And what I tried to do there was leave some space after each fraction. There's no grouping symbols in this one. It's just a plus divided by and another plus. So actually the space is not the best way to start this. No, I missed one. Sorry. Times 3/5. That's what I'm missing. So I left space for some of these, but it's really not the right time for that because addition is not the first thing we're going to do. There's no parentheses or exponents, so we're going to do multiplication and division left to right. That means we do the multiplication first, then the division. This will be, we'll come back to that. But 5/6 times 3/5, the 5s will cancel, leaving me with 3/6. That can be simplified further. We'll get to that. But the first step here is to do that multiplication. Now, there's still a division, so I'm still not ready for the additions here. The 3 cancels with the 6, leaving a 2 and a 1 up there. And the 2 cancels, leaving just 1, really. So there's some cancellation, and my division is gonna, well, I haven't done my, that's not right. I need to change my 3/6 divided by 2/10. This is the next thing we need to do, but the way that we do division is by multiplying by the reciprocal. So I flipped my divisor, 10 halves instead of 2/10. And now I can cancel some, like I could have canceled some of this before, but this 3 and the 6 cancel, leaving a 1 upstairs and a 2 downstairs. Also, the 10 and the 2 cancel, leaving a 5 and a 1. So -9/10 plus 1 times 5 is 5, 2 times 1 is 2, plus 2/7. And now I'm ready to do my addition. Well, I need the LCM for this one because I've got 3 different denominators. And I'm going to need a factor of 5 and a factor of 2, and I already got a factor of 2, and a factor of 7. So 70 is the least common multiple. I need to multiply the first fraction -9/10 by 7/7 to get that common denominator. I need to multiply the second fraction by, let's see, it's got a factor of 2, but I need the factor of 5 and 7, that's 35, and I need to multiply this one by the factors of 5 and 2 to get 70. That's 2/7 times 10/10. Now I'm going to carry out the multiplication. It's -63/70 plus 5 times 135. For this one I turned to a calculator. It's 135 over 70 plus 2 times 10 is 20 over 70. And then if I add those, well, this one's negative, so this is the first operation I would do, and it would give me the result of these. But when I do -63 plus 135 plus 20, I get 132/70. And then for Hawks, you do need to reduce this. These are both even numbers, so this is 166/35, and I think that's in lowest terms. 66/35. I think that's in lowest terms because 66 is only divisible by 6 and 11, or 2, 3, and 11, and 35 is only divisible by 5 and 7, so that there's no more common factors. That was a little messier than I thought it was, but so for number 10, I've got another one with grouping and exponents. So 3 minus 4 times 1 minus 2 squared. Parentheses are there, so I need to work within the parentheses. Now inside the parentheses, there's 2 subtractions, but multiplication comes first. So this is 3 minus 4 times 1 is 4 minus 2 squared. And I work from left to right. So I've got 2 subtractions. I do the left one first as I read left to right. 3 minus 4 is -1. And then -1 minus 2 is -3. And now I've simplified the inside of the parentheses. The only thing left to do is square it. -3 times -3 is 9. number 11, I got 3 times 7 plus 4 minus 3 divided by 3 squared. Similar to that last one, we've got the grouping symbols and an exponent, but in here, there's an addition and a subtraction, but division comes first. So I'm going to do 3 divided by 3 and keep it as a subtraction here. 3 times 7 plus 4 minus 3 divided by 3 is 1. The next step, I've still got grouping symbols with operations. I need to do addition and subtraction, but it's left to right, so this addition comes first. 3 times 7 plus 4 is 11, minus 1 squared. And then 11 minus 1 is 10 squared. So this is 3 times, now exponent comes next. 10 squared is 100, and 3 times 100 is 300. Four times 2 minus 8 plus 1 squared is the next one. So in the grouping symbol, that's a 9. That's really the first thing we do. So it's 4 times 2 minus 9 squared. You can put the parentheses here. It's still just 9 squared. Exponents is next. So we need to take that 9 to this second power, 9 squared. 4 times 2 minus 81. Now multiplication comes up next. 4 times 2 is 8 minus 81. And 8 minus 81, that's going to be negative 73. The next one's kind of a big expression, but it's all whole numbers. So absolute value of 18 minus 24, then a bracket, 33 divided by absolute value of 6 minus 3 minus 2 squared, close bracket. So there's a couple absolute value expressions, and remember those are grouped expressions. So this is a group of symbols, just like as if it was in parentheses, only the absolute value bars mean something additional. For example, this one also grouped with absolute value bars. 18 minus 24 is negative 6. And then in these brackets, 33 divided by the absolute, well, I'll leave it as absolute value. 6 minus 3, that's in the grouping symbol, so I need to do that subtraction. It's 3 minus 2 squared. There's a few things that I can simplify here. Here I can just change it to a 6, because it's absolute value of negative 6. This is also, similarly, absolute value of 3 is 3. So 6, bracket 33 divided by 3 minus, this is actually the next thing that we need to do, is take that exponent. So you could do it as, just write it down as 2 squared and do another step to change this to a 4. 2 squared is 4. Now I've got to work in this grouping symbol. There's nothing to do here, but these are grouped. And in here, division comes first, so this is going to be 6 times 33 divided by 3 is 11, and then 11 minus 4 is 7, and 6 times 7 is 42. For number 14, negative 1.5 in absolute value times 2.2 minus 6.6 times 1.3. And you got to be a little bit careful with your decimal points and your times dots. These are decimal points down at the floor, and then the multiplication dot is a center dot. Lower dots, center dot. The first thing to look for here is in the grouping symbol, absolute value of negative 1.5. It doesn't look like there's any operations there, but we can simplify it by writing just 1.5 times 2.2 minus 6.6 times 1.3. Now these are all two-digit numbers that I have to multiply. There's decimals, they're small two-digit numbers, but it's still much easier to do with a calculator. So I'm going to write down my products here. Multiplying 1.5 times 2.2, I get 3.3. Minus 6.6 times 1.3 is 8.58. And then if I do, again on the calculator, 3.3 minus 8.58, I get negative 5.28. And that's it. Finally, I've got another fraction one. It's not nearly as big as the last one. But number 15 is 2 divided by 6 divided by 5 over 7 minus 1 over 2 divided by 4 over 8. So fractions. And the first thing we're doing is division. We can actually do both of these divisions because they're separated by that. We can kind of do two steps at once because they're not connected. But dividing by a fraction, what I really want to do is 2/6 times 7/5. So multiplying by the reciprocal minus 1/2 times 8/4. Now before I actually do the multiplication, I'm going to cancel some common factors. This one, the only common factor upstairs and downstairs is 2. I can cancel that 2, gives a 1 and a 3. Over here though, oh yeah, we can go ahead and complete this one. This is 1 times 7 over 3 times 5. But for this one, we can cancel much more. We can cancel a factor of 2 with the 8. But then that's 4 over 4, which is 1 over 1, or just 1. And all I have left here is 1. This is 1. 1 over 1, but that's the same thing. Now, to combine these, for that last operation, I need a common denominator, which is just this denominator. So I can multiply 1 by 15 over 15, or have 7/15 minus 15/15. And that's the same denominator, so it's just 7 minus 15, negative 8, over the common denominator.